Hello everyone. In the last video, I told you while talking about fundamentals of array why I wanted to talk about it. What do we miss usually in our expositions of an array? And secondly, we discussed about how should we view the processor and how should we view the memory. In particular, we talked about that a processor, its life consists of fetch and execute instructions, and those fetch and execute instructions refer to memory addresses. And we saw that we should visualize a memory as an indexed sequence of bytes, a linear sequence of bytes. And now, with that background, we are ready to cover the main topic, namely, what is an array? To be able to answer this question, what we should consider is to try to find out what happens when you allocate an array in a C-like language. What happens when in a C-like language you say int x10? Note that we are emphasizing it to be C because languages like Java or Python, when you allocate arrays in those languages, they are very different from C-like languages, because C is much closer to the bare metal, and it is important for us to understand what is happening foundationally. And what Java or Python do when you allocate an array, we will have a quick look at them after we consider the basics of an array. So when in a C-like language, or a C, let's say C or C++, you say int x10, what you are saying is please allocate an integer array of size 10. So what happens is that two things happen. First, OS finds a continuous block of 40 bytes and returns the address of first of those bytes. So x actually, so why 40 bytes? Because integer is of size 4 and 10 is the number of elements you want in your array. So it will allocate a continuous block of 40 bytes and then return you the address of first of those bytes. So let's try to have a look into what happens from memory point of view. So this is our RAM, which is an indexed array, an indexed sequence of bytes. So there is byte 0, there is byte 1, there is byte 2, there is byte 3, there is byte 4, and so on. And let's say that the OS finds a continuous block of 40 bytes starting from byte number 5. So starting from byte number 5 to byte number 5 plus 40 minus 1 is equal to 44. So byte number 5 to 44 is reserved for your array. Maybe other bytes were used for some other purpose. Maybe your source code, not the source code, but the compiled and machine code was being stored in some memory location. Some other memory locations were being used for maybe your variables which you are using in your program. So when you asked for this excuse me, when you ask for these 40 bytes, OS finds out a continuous chunk of 40 bytes and gives it to you. And so now when you say x0 equal to, let's say, 127, then what happens is that first 4 bytes of the allocated bytes, namely byte numbers 5, 6, 7 and 8, they are supposed to be making up your first element of the allocated array, and you store 127 in these 4 bytes. you take the binary representation of these 127, of the number 127. There is some ones complement, twos complement. So you find some format, you find the representation of 127 in some format and store it in these 4 bytes. When you say x1 equal to, let's say, 4678, then this number 4678 gets stored in bytes 9, 10, 11 and 12. Okay, so the important property of the array that we wish to emphasize is that address of ith element of array is equal to x plus 4 star I. So address of 0th element, so you know x was 5 because 5 was the beginning address. So address of 0th element is 5, address of first element is 5 plus 4, 9, and so on. And this will always hold true because, as we have seen earlier, an OS has found us a continuous sequence of bytes. So it is not the case that first few elements of the array are here and then there is a jump and then there are other few elements of the array. That is not the case. So given I, you can find the address of the ith element of the array very easily. Note that this property is not true in, for example, linked list, where you need to traverse element by element to get to the ith element. So to find out the nth element, you need order n time. But here, to find out the nth element, you need order 1 time. Similarly, in trees there is no ordering of elements. So there is no concept of ith element. So the concept that ith element can be retrieved in order 1 time is only a property, is a very unique property of arrays. So let's write it down. Array is a data structure in which ith element can be retrieved in order 1 time, and this thing can happen only because the array layout is contiguous in memory. All right. Now that so this is what I wanted to emphasize about arrays. Now a note about higher level languages. So in Python, before we go to the higher level languages, note that in C-like languages, array cannot be extended, as in other words, size of array is fixed. And why is the size of array fixed? It is fixed because once the OS gave you some 40 blocks, let's say that the OS gave you some 40 blocks, then now next, if you want to extend it to, let's say, 44th, if you want to increase the element or increase the size of your array by 1 more unit, then there is no guarantee that some other elements would not be stored at those locations, right? So there is no guarantee that you will be able to get your new memory addresses contiguous to this particular memory address. There is nothing like that. So it is just not there. Array is not extendable. Fundamentally, an array is not extendable. Now but in languages like Python, so now let's come to the higher level languages. In languages like C is also a high level language, but Python is a higher level language, and even Java is slightly lower level than Python, but higher level than C or C++. So in languages like Python, you would have seen that the array can be extended. And the way Python achieves this extension of the array, and even in Java there is there is something called array list, which is a resizable array. So when you have such structures in Python and Java which are known as sort of list or array, but they are not really array in the foundational sense of the word. The way they achieve their extension is that, okay, maybe they will allocate an array, and when you want to extend the array, maybe initially you have a size 10, and then when you want to make it to size 20, they will find some other contiguous 20 integer range in some other part of the memory, and then they will copy it from the original location to the new location. So and maybe if you allocate an array of size 10, if you say to Python, I want to allocate an array of size 10, maybe actually it will, in from OS it will ask actually size 20, because it knows that maybe you will try to extend the array size, extend the array later on. So Python and Java, those languages which provide you this extended array, which extensible array, resizable array type of concept, they do all these hacky kind of things in the back. And that is why this is one of the reasons their performance is slightly lesser than C type of languages. In fact, it is a lot lesser than C type of languages. But as a programmer, your life is simpler, because you still can think of array as just a list of elements and not worry about how exactly it is being implemented. So this is what I wanted to tell you about arrays. In some later lecture, we will consider some other data structures. Thank you very much.